kids, good morning. This is your lecture for today. This is a lecture that you missed out on Thursday because there was a power outrage on Thursday, so we didn't have the chance to do the lecture. So this is the lecture for Thursday. That's week 5, lecture 3, and it's using grammar's rule to find the unknown or find the values of x, y, and z in the system of linear equations. Okay, so Grammar's rule, if a system of n linear equations is in n variables, has a coefficient matrix with non-zero determinant, then the solution of the system equation is given by these formulas. So that's x, y, and z. I think if you recall this symbol, it means determinant, and I already taught you how to find determinant. But there's also a shortcut that I was teaching in a few tutorial groups on how to find the determinants without finding the minus and cofactors. So we have determinant of ax divided by determinant of a, and you get the value of x. Same with y, determinant of ay divided by determinant of a, and z, determinant of az divided by the determinant of a. So I'll just quickly show you how what are these? What are ax, what is ay, and what is az? Okay, let's use Grammar's rule to solve the system of linear equations. Firstly, you need to write it in a matrix, coefficient matrix form. So coefficient matrix form, you wrote the coefficients here of x, y, and z there. Then you have to write the constants or the right hand side on a separate matrix. And then we have to find the determinant of A. So this is matrix A. Matrix A is the original matrix. So the shortcut is you repeat these first two columns, column 1 and column 2. You just write it because you have this matrix. So now we're going to find the determinant. You just write the two columns here on the right hand side of the matrix. Column 1 or column 2. And then you do your diagonals. Firstly, this first diagonal, you start from here upwards, and then you multiply. So 4 times 0 times -1, that's 0. And then you add or plus the second diagonal, which is 3 times 1 times 2, that's 6. And then you plus another diagonal, which is -4 times 2 times -3, and more positive 24. Because -4 times 2, that's -8. -8 times -3, and more positive 24. Okay, so those are the first 3 diagonals, and then you add across, you get 30. Okay, second diagonal, set of diagonals, you start from here. So you multiply as well, then you get a 0. Same with this one, you multiply across, you get 4. And the last diagonal is you multiply across as well, and you get 16. So you have to add across, you get 20. So the formula for finding the diagonal, you just any number you get from the first diagonal minus any number you get from the second diagonal. So that's 30 minus 20. Therefore, our determinant for A is 10. Okay, now we have our determinant of A. Let's find AX. So AX is when we replace the column X by this constant matrix. Matrix as a constant. We just replace the column X. So we get a new matrix like this. We have a matrix here. So now this first column now becomes this column. So column 2 and column 3 remains the same, but this one is your new column. And then you have to find the determinants of AX. In the same case, you repeat the first 2 columns, which is now you have the new column, 103 or 102. And then our second column remains the same, is 2, 0, -4. And we have to do our diagonals as well. Multiply here. Do this as well, we multiply. And lastly, this one we also multiply. So if you have a 0 in the column or in the diagonal, you can make it a 0 because they are multiplied all together. So when you have just one 0 in here or in here, you can make it a 0 kali. So there's no 0, so you get a non-zero answer. The same, we have to do another diagonal. From here we get 0 as well. That's -4 and also 0. So we add that, we get negative 4. So remember the formula is any value here, so that's 4 minus negative 4. Therefore, determinant of AX only 8, because 4 minus negative 4, that's same as 4 plus 4. Okay, AY, same case, we replace the column Y with this matrix, and we get a new matrix. So go for email column X, this same column here, but we're only replacing column Y, which is this one. And also column 3, column Z, but column 3 remains the same for you. We are only replacing the Y column, or the second column here. Okay, same thing, we have to calculate the determinant or do the diagonals. So for, again, we need to repeat the first column, which is this column, E, and also the second new column, we repeat it here. Okay, if I do diagonals, multiply, and that also multiply lunga, and also again multiply again, because 2 times 2, that's 4, 4 times negative 3, then more negative 12, and you add across, you get negative 9. 3 plus negative 12, that's same as 3 minus 12, and more negative 9. Okay, another one, another diagonal, sabay lunga lalu, that's 0, that's negative 2, and that's 8. So negative 2 plus 8, you get 6. And of course, remember the formula, negative 9 minus 6. Negative 9 minus 6, we get negative 15. So that's the determinant of AY. Okay, and lastly, we need to replace the column Z, or the third column, by this matrix. And we have our new matrix, which is this one. And now, I think I will go for diagonals. I just quickly calculate that. So the determinant of AZ is negative 16. When I do the diagonal, I'm not doing the diagonals here, but you can do it by yourself. I'm over negative 16. So now we have our AX, AY, AZ. So let's go back. So AX, or determinant of AX, or 8. And determinant of A, or 10. Or formula lang sa to get the value of X, a determinant of AX divided by determinant of A, we got 8 over 10. Therefore, our X value is 4 over 5. Same with Y. Finding the value of Y. Replace the Y column. Multiply determinant in negative 15. And with determinant of A, which is 10, divide for ila iyo. And we get our value of Y, which is negative 3 over 2. And lastly, our Z, AZ, determinant of LZ, divide by determinant of 10, or A, which is 10, and our Z value is negative 8 over 5. So therefore, you can finally write your answer as this. Remember, you need to write your answer like this in your last answer. And those are our answers for X, Y, and Z. And of course, if you need to prove it, you can sub these values into the original equations and to see if you get the right hand side. Okay, let's do another example. Same case for we write in coefficient matrix, separate matrix layer, and then we need to find the determinants. I already taught you the determinants of doing the diagonal, so you do it yourself. I'm just going to skip it through. So this is determinant of A, which is 25. Okay, for AX, replace the column X by this one, and I find the determinant of AX, which is negative 25. Determinant of LA, which is 25. So we can simply just find X value here, which is negative 25 or 25. Let's mark X value in negative 1. Okay, AY, same case. We replace the column Y with the constant matrix. So if we along a determinant, which is 50, and we already know the determinant of A is 25, so we divide the 2, and we get a Y value of 2. And lastly, the replacement of Z column, we find the determinant of AZ, which is also 25. Our determinant of A was 25, so we divide the 2. Therefore, our Z is equals to 1. And that means our answer should be, the final answer is X equals negative 1, Y equals 2, and Z equals to 1. Okay, that should do it for today. You have your classroom activity here, so please pause the video here and try to attempt because I also have the answers, so you can check your answers. I have all the answers here, and to check your answers after you attempt. And that's our lecture for today, and I'll see you when I see you.